great YouTube channel. Okay, hi everyone. My name is Evgeny Shvarov, and today it's our kickoff webinar for the AI contest with InterSystems Iris. And today we're gonna introduce you how you can build AI and ML solutions with InterSystems Iris as a backend using several features of InterSystems Iris data platform. And I think, and the agenda is the following. So I think we will cover today how to load the data into InterSystems Iris, how to use integrated ML, and Alex Kovacevic will do this demo. Also, we will see how to use our gateway is the new feature of InterSystems Iris, which was introduced in the version in the release 2021 this month, and Théophile Thierry will demo it. And also there will be very hot new feature of InterSystems Iris, which is embedded Python, and all the participants of this contest will be able to use it next week, I believe. So, and Bob Kuszewski, product manager of InterSystems, will demo embedded Python feature. Okay, and I will start with data import. InterSystems Iris is a data platform, so of course it can deal with data. And if you gonna build any AI ML solution, you of course the first task is how to load the data into it, right? I will do a demo how you can easily load CSV data in a CSV format. Okay, I'll share my screen. Can you see my screen?
Yes.
Okay, and first of all, you will need InterSystems Iris, and for this you can use any template we prepared you on Open Exchange site. So you can just open InterSystems Open Exchange and look for a template. Search for a template, and we will take, for example, InterSystems Iris dev template, one of the simplest GitHub repositories with which is Dockerized. So you can click on use this template, and ML. And I will create a new repository out from this template. ML contest 2021, and we'll clone it. And I will open it in VS Code, which is the most suitable tool to develop InterSystems Iris solutions. And I will clone this repository. And my VS Code already contains InterSystems object scripts extensions. So it's cloning it at the moment. Usually it goes much faster. Maybe when we share the screen, it slows down. So it is really slow. So I will better open another screen that I have locally with VS Code. It is the same template, right? And I will right click and restart it, or restart it on Docker Compose. Okay, we will. One of the way how you can deal with data, it's to import the data you need from CSV file. And for this, we have on Open Exchange, we have a very nice utility that is called CSV Gen UI. You can search for CSV Gen and find it here, and it is distributed via ZPM module. So you can click on this ZPM script and go back to your VS Code, to our VS Code, and click on this the object script menu to open Iris terminal to it. Yes, and here you just paste this command ZPM install CSV Gen UI, and it will install this package into your Iris. So it installed actually 3 dependent packages anyway. So what we need is CSV Gen UI that then okay, we need to open it here, CSP is CSV Gen /index HTML. Yes, I missed this one letter here. I think I missed something else. Just wait just a second.
I think the URL was just set. You wrote CSG then.
CSG. Okay, yes. Thank you. Thank you guys for your help. Yes, and here we have a nice UI that allows you to import CSV files into InterSystems Iris just by drag and drop operation. And I have a file from my colleague Aleksandar Kovacevic, Bankust CSV, and I drag and drop it from folder, just from drag and drop it here, and we see that it contains some data, like first few lines, and the separator is obviously a comma, and we say what's the name of class that will be generated from this for the CSV user cost, something like that. So we create, and the green message tells you that everything is fine. So we have a class created and the data loaded. So it is simple like that. You just install one package, SysVgen UI, and you can drag and drop data. Also, if you want, if you have your data like somewhere in internet, you can import and create classes just from a URL that points to a certain CSV file somewhere in internet. Another question will be, okay, we imported data, how we can know that the data is inside, so how can we deal with that? And this is a very good question from myself. So we, first of all, of course, we can go to management portal and see this data. So I open management portal and go to System Explorer, for example, to SQL. And yes, we're in a proper namespace, and we see this Bancost class. And we execute the query and we see the data. Perfect. And also you can deal with this data via REST API, and you can also deal with the data via different industry standard tools for data management for dealing with data, like dbeaver or data grip, and both you can find on InterSystems Open Exchange also. So you can, for example, data grip just made a new release here, so you can find it here easily, and dbeaver is also here. Yes, so you can find it and download and install it and use it and connect to Iris via JDBC driver. Another option, if you don't if you don't have any CSV file and you just need any data to play with, there are some standard packages like Titanic or countries that you can find here in Open Exchange. For example, we can look for Titanic, and here is the data set that is distributed via ZPM, and you just copy this line, you go to VS Code, okay, and you type this here, and you have data set installed very fast and easy. And if you check this here, updated here, we see in new table Titanic and the data for this, data and classes for this. Okay, great. So I think this is enough for data import. If you have any more questions, so please don't hesitate to ask it in Discord. And I give the floor to Aleksandar Kovacevic to present an integrated ML. Aleksandar? Yes, I'll stop sharing the screen. We don't hear you, Aleksandar. You're on mute, Aleksandar.
Yes, now I'm not on mute anymore. So first of all, I want to actually explain what exactly integrated ML is. So it will be a very brief introduction, so I hope you're gonna keep on understanding. So the point of the machine learning is that you actually try to get the machine to learn from the data, right? And in this sense, you have certain kind of a process that you need to go through. In the sense of first, you have to acquire data, do a data preparation, and once you have a data ready for the machine learning process, then you need to make the machine, or to figure out which information from this, which information from those are important features, so that's called features. So what kind of input things would influence greatly the model or the prediction itself. Upon that, you have to figure out also which model fits best to the problem. and also then to do training, and then do a certain amount of parameter tunings, and of course do the deployment of the model. This altogether is a regular process that every data scientist does when he makes the machine learning process. What AutoML is actually is the set of best practices that a data scientist has gathered on which way you can automatize certain kind of problems that are existing within a machine learning, and that you can simply just generate the models on its own. Because of that, you're able to this is exactly what InterML is. It's actually a front end in the form of a SQL interface, which allows you with a very simple SQL statements to run the AutoML which runs behind. So what that means, you have a certain front end like a create a model, train model, and select predict, and this all runs using a SQL processor into a certain background under the hood engines, which are called here in this case ML providers, which are then doing magic for you. So, and we have in our own sense, within InterSystems, we have the integrated version of or built-in version of AutoML, which is set of certain algorithms that we have, models that we have came up with throughout our own experience, like a ski-hit-learn or XGBoost and TensorFlow. But we have also enabled the possibility for example, using of other AutoML providers like H2O, which is open source framework, and also one of the state-of-the-art tool called DataRobot. Which means these providers, as far as I explained, this is all of them done in different ways, how they are connected with InterSystems Iris. But what the syntax I would like to first go to explain a bit. So that means that first we are going to create a model, make model definition by itself, which is actually just the definition, the metadata, what model means to do. So what needs to predict and what data it should use to predict it. On the other sense, once we start training the model, this is the moment when he does all the possible features. So first it makes the training run, which means that it will start all the possible things at these steps, which I mentioned before, like a feature engineering and parameter tuning and so on and so on. And it will then result in a trained model, which is, as you can see here at the end. And this will gonna be then generating the model which we're gonna use then to make the predictions. With a validate model, this is very important part because usually the more data that you train on, usually you should have another set of data that you can try to see how good is this model performing itself. And that's why this is the validation which is being used, where you can get a certain amount of metrics which define exactly how good the model is. This is what we actually need for everyday process, and this is it simplifies the overall operationalization of the integrated ML. At the end, only thing you need to do in order to use the model is simply use the predict function, which gives you immediately the prediction based on what the inputs are. Or if you want to go a bit more into detail, you can also get use a probability function, which gives you opportunity to see exact probability which it calculated for this particular situation. So enough of the chit chat. I think we should definitely go on with the next. So here what I have is an InterSystems Iris data platform, and inside is the integrated SQL editor. This is already running inside, and we have already data loaded inside. So as you can see, there's a whole set of things, and similar to what Evgeny has said, you can easily load or your own information. So what we have here is, and this is what we currently going to use as a use case, is imagine that we are a certain kind of a bank, and we offer certain credit loans. Our customer
Aleksandar,
yes.
is uh-huh. I thought we just lost your. Now I think everything's okay. Now, please go ahead.
Yeah. Sorry. So the point is that what I want to show here is exactly what is the bank. So we have certain amount of information, which is of course aggregated information about the customers that we have own in a bank, for example, and all kind of information about, for example, their income, education, and so on and so on. And also, if you go a bit further, information about how often do they do their own transactions inside of the bank, what kind of stuff they do with the credit cards that they own in the bank. And along with that, we have this attrition flag, which means if this customer is existing customer or has the customer who has left us. This is exactly the thing which we want to predict in this case. We want to see, based on this kind of information from the left side, we want to predict if the customer will leave the bank or not. And this is very valuable information because you can imagine then you can do certain amount of special deals for this kind of customers, or analyze this kind of customers, what and why did they leave, and also then give them possibility to stay. So how shall we do this? First thing that we do is we make, as we already have said, we make a create model statement. So how does this create model statement? I'm gonna simply copy paste the SQL statements themselves to make it a bit quicker. So how it looks is create model, and then we name the model that in this case we'll say will leave. And then the predicting attrition flag. So the result of this model would be either existing customer or attriting customer. See here, attrited customer. So this will be the results in a string form of string. And he will take all the information from this table as a result. So when we run this, so it's finished. Let us take a look at what actually has happened inside. So there is all this information about model definitions are stored in each one of the specific tables. In this case, in these ML models, which actually defines the model. So they exactly picked up this what name of the model, and also all the possible columns that it requires. And here also is a default training, which means this is the question that training. So what split up and then we can run train. Sorry, have a slow see. Not about the higher, it's about my computer itself. So what we actually the first 9,000 rows of the bank customer, this bank table. This does not really, it's not really the perfect way how to split the table and to keep the training set and validation set. But in this sense, we're gonna just use it like this so that in hope that the targets or these attrition flags are distributed properly within the evenly or uniformly within the table. It might not be the case, but just for the sake of a demo, it's more than enough. This training is running roughly 1 minute, at least it was running before. In this case, because of this demo in this WebEx, everything is running for some reason very slow. So I hope it will not last that long. And what we can then achieve from that is simply we're gonna get the training run, which we're gonna have the exact amount of information which has happened, which features has been extracted, what has been selected as important features for the machine learning, and then has been done performing training upon the multiple models. And this is important to say. In general, this model, when you are as a data scientist, you usually use one model, second model, third model. Each individual model takes much less time to do this. Here, we are doing the job of one person who has to also implement all of these things and takes weeks to implement. In here, it's automated, all the process of figuring out what the features should be, and then figuring out the code, what should be used to extract all these features, and then implementing all the models that you want to choose, that you know that it's appropriate for the problem, which could be a classification problem, regression problem, so it means, and then on top of that, you need to, so an enormous amount of coding that you need to do as a data scientist. Even if you are a data scientist alone, it's already there a big issue that what you have is that you consume a lot of time just to do something which maybe AutoML can already produce in pretty well good time. I don't want to say in this sense that this AutoML can replace the data scientist itself, but it can really help out quickening the problems and the straightforward issues which are happening to be simply they took over by the AutoML, and then data scientists can focus on the real, difficult issues which are not so easy to extract in terms of, for example, the feature engineering or explorative data analysis of the data. What exactly is there to be predicted and how to be predicted? As a Marfilo always does it, this does not take more than 1 minute. So we have to I have to wait a bit for this. Instead, I would like to also explain an additional point on the side. So as we have said, there is a couple of providers, and I will going to show you one provider which is here, which I'm currently using. It's by default, it's AutoML. It means it's a built-in. It's named like that. But it's built-in InterSystems AutoML. Next one I'm going to show you is the data robot. And what is very interesting is that you can use the data robot from the point of view of using a trial run, which for these purposes of this contest, you might be actually good enough, at least for you, to have a feeling of how does it work together. What you need to do is simply to fill up this information. This you get for around 14 days of workable data robot account. And based on that, you can then do the following steps further that I'm going to show you. So I will going to continue with this part, and I hope that original training will going to finish by the time we finish the webinar. So what you're seeing here is your data robot account. This is what you usually come to have. So what you usually need to do in order to connect the data robot with integrated ML is to go into your profile option here and go to the developer tools and so what it is useful, like when you're developing something that or to anything, is developer keys, and you have to just for your own self know what is used for, so what app is used. In my case, I'm using currently ML, and this is short for integrated ML, and this is the you get this code, then you can just copy the clip here and then use it into the configuration I'm going to show you now. So unfortunately, the train is running way too slow for my to the configuration part. So in order to configure or to connect integrated ML with a data robot, you need to go into the system administration, configuration, and then you have to see this new feature called machine learning configurations. When you click there, you can just create new configuration. I have created already one which is for the trial, but and I can immediately show what is being done here. So you name it the way you want. I'm currently wrote in this way because just to know that this is a trial version itself. In general, this is the name that you're going to use when you want to change the provider. We're going to show you this also later. How do you change this provider programmatically? Here you should define exactly which provider you want to use. This is data robot. And then as an owner, you define a user inside of the InterSystems iris, which should be using this, which is allowed to use this provider. In this case, I use super user, which is not really recommended. Maybe it would be in general case, would be better to have some user which is a bit more restricted. And then you define the URL. For the case of the trial versions, there is an app2 URL. When you have your own license, is usually then app.datarobot.com. And here is where you copy your API token that you have generated from the data robot side. And that's it from the connection side. This is all what you need to do to connect to data robot. Oh, okay. So finally it's finished. So now I can continue with regular stuff. And so this we have trained this model, and we want to see what has actually happened. So first we want to show is the training runs. So first you can see that here there is a new run. This has its own run name. Provider is defined as well, because honestly, from the same model definition, you can also use the different providers on the same model definition, and they will create their own models. And that's why there's every cell, every time you do the training, it will gonna make a new cell here. And you can see here the training log is exactly what has happened within, and also then what query it has been run on. I want to just show then quickly what is happening behind, and I have developed, this is not part of the InterSystems series, but I just like to show this. Here's the with the answer, this is the name of the run that you've seen, and general, I think, works faster. So what it happens, I'm looking here, training of one training. So as you can see here, and I highlighted, he picked up all the information, all inputs to the table, and then he tries to follow the kind of, so he can and then that transform what is done, try to like explode the amount of features that we use. We don't have the news, for example, day of week, month of year, we have daytime, and then it's pretty much useful as a feature. For example, on Saturdays, usually the shopping spree is much higher than on Monday. So this is, for example, one of the very useful information for the machine learning. He cannot pick it up from the milliseconds since 1970, how usually the data is being stored and data time is being stored. But if you have exact number 1 to 7, this is already much more useful information. And the same goes for the other things. And he explodes this with an enormous amount of features, and then tries to figure out the correlations. That means how much are actually from all these features are useful features, and how much are actually influencing the model. And he picked up to 26. And then now when he's done with the feature engineering, then he's preparing the data for the training. And he has also evaluated the model, that it's a classification model. The classification model is exactly this thing that you are having, what we want to do. Either the customer is going to leave the bank or not. And this is the classification at this point. And then he's trying to find a best estimator for this problem. And then he's trying one algorithm, second algorithm, and so on, and doing all the trainings possible. And then in the end, he results with a one champion model, which then is stored in the database. And this is, in this case, random forest classifier in case you're in. So this is what is under the hood, so to say. What we have further is, let's see then, how is this then being stored inside of the, when have this model, then being stored is there's an table, this model, which is find it very timestamp. This point you can go to get and take a look, because train the model, we want to do the validation of the model. So hoping I'm not running too much on the information. We are having here the validate model, we live from, and I left then the part of the data set, which is from 9,000 onwards, which is 10,420 is altogether size of the data set, and we can then execute it and run it the way to see. And we can see then, based on this validation model, here we're going to check how does this model behaves with the rest of the we have done this, and we can take a look then what was the result. So in order to do this, we just need to then run the following statement where all these validation runs are being stored. And here we can see that accuracy is 77%. So this might not be the best possible solution, but it's a working point. But that means that probably we need more data or something else to improve the model. As we have mentioned before, the same we can do also to, in order to change, for example, the MAML provider and make, for example, some other provider which might provide some better results, then we can set ML configuration and name it as possible. For example, as I mentioned before, we have run configuration for the data robot trial, and we can set it up here like this. That's all we need to do to let the iris know that, okay, we want to use data robot trial. And then you can start all over again. You don't even need to create model itself. You can just look back again and look for the, okay, I want to train, use exactly the same statement to run a train model. When this happens, then the iris is sending this information to the data robot, and data robot is then performing certain amount of AutoML features. So let us just quickly take a look at what is happening within the data robot. So here is the our model that is came in. So it has been flow data, and then so this rather like all over with these details, but rather to show you just how does it look like in general. So what we have done in a previous project is using he find a model and find exactly which you want to use. Here you have also opportunity metric you want to use to define which model is the best one, and you can of course set yourself which one is the best champion model. Which it's also very important is to take a look from this point of view is which of the models is performing how well, which this makes it very easy for you to choose. Okay, I want to, for example, choose very quick model, which it's not really important that much the accuracy as much as it is as quick as possible. I mean, you can always do a look at this graphic and take a look and see which is the best option for you. And whenever you choose one model, it is stored like this, and from InterSystems side, and from Iris side, it's transparent. It's like nothing has changed. You can just use whatever model has been decided here. Also, what is additional, very interesting, according to this thing, is also to see feature importance. This is something, a way for you to discover why does certain machine learning model behaves in a certain way. Why he has decided this. What is most important thing about it. And this is where we go from this kind of a point of view. We have a certain amount of features, and we can see which one of features influence the result greatly. In our case, this total transaction amount is the 100% feature to use. It's defined exactly what is need to be done. And this is also one thing that the last thing that I'm going to show is, for example, here you can also see how the data is behaving according to this running. So you can see that exactly how we expected that. So this yellow line is the amount, percentage of people who are existing customers towards so that means that most likely you're gonna be the attributed customer if you're having very low amount of transactions. More the transactions you have, so more longer you are with a bank, you less likely you're gonna quit. Solution that was here. Food. Many features they also so for my time. Thank you very much, Paul. That was the next.
Thanks, Alexander. This was very thorough. Thank you for this demo and very helpful. And now I give the floor to Théophile Thierry, and Théophile will present us our gateway, that new feature of Iris that was introduced in the latest release, along with Python gateway. And as you know, R and Python are very heavily used for building ML and AI solutions. So Théophile, please, welcome to start.
Thank you, Evgeny. So, hi, I'm going to present you the R gateway, and I'm going to do so by presenting you the template that you have access to in the details of the contest. It is a Git repository, and it's a template for using the new R gateway for Iris 21. So, this is the architecture of this template. It is contained of 3 containers. So that is how the R gateway functions. There is the Iris container, which contains Iris, and it will discuss with the R server on another container, the R container, this one, through a Java gateway that we decided to put in a 3rd container. So we separated the R gateway into these 3 parts into 3 different containers. The Iris container and the R containers are going to have, for the sake of this demonstration, are going to have the same data. They're going to have access to the same data. So we did so by binding the /temp/data in the Iris container and in the R container to a local data folder where there is the infamous abalone.csv dataset. It's a classic dataset about measurements of abalone plants. So this is a clone of this repository. As you can see, we have the local data folder with the measurements of the abalone plants. This data is loaded into Iris with CSVGen that you know all about by now. So if we look in my instance of Iris, we'll see that the CSVGen has generated an object with all the properties of each abalone lines and methods to import this CSV. So we have this data in the Iris container. And to finish with the architecture, the R container is also binded with another of our local folder where we have put an R script with 5 functions or 4 functions. So I'm going to show you this. This is the R local folder, and it is binded with the /temp/R folder in the R container. It contains 5 functions that I will demo and another bits of functions. So we have functions like get mode, get length, and 3 ways to create a histogram and to save them into a file. So how do we set up this template? It's really easy. We just have to clone this repository. So we can run this command right here, or we can do the way Evgeny did through the VS Code IDE. And then we just have to do a Docker compose up. So I already composed the images. The 3 of them are here. So I'm using the Docker add-on for VS Code. The 3 of them are here. They're already linked and everything. And so we can use them, can play with them. In order to present the different ways of doing things with the R gateway, we have implemented a class that is right here in the Iris file. It's a class that's named demo.rgateway, and there are 5 class methods in it in order to show the different aspects of the R gateway. So let's start with the first one. The first one is a class method that is that is called run_eval, and it will enable us to do a random command in R. So how do we do that? First, we need to create a gateway. And then with this gateway, we are going to connect it to the Java gateway. So as you may have seen in the architecture, we are going to access the Java gateway through this port, and between the Java gateway and the RServe is going to be with this port. So everything is set up in the Docker compose file. This is the port that we set up with our local machine, and they are here in the parameters of our class. So we connect this gateway to the Java gateway. We connect this gateway to the Java gateway with these parameters. And then we just have to bind this gateway to the RServe with this line. And so we have a connection. With this connection, this C object, we can do everything we want. For example, in this little method, we are going to evaluate with the eval function the following command, R command. So eval is a function that will enable us to evaluate on the RServe every command that we put between the codes right here. Then once we have this object, we can do a as a string to write it and have the proper output. Then we just close the connection and we disconnect the gateway. So I'm going to run this command right now. I'm going to open the terminal in Docker in the Iris container. So this is a terminal in the Iris container. And if I do this command, I'm going to do the method. We're going to see that it worked. The Iris connected with the RServe through the Java gateway. And we know now that the R version in the R container is this one. So this is one way to evaluate commands through Iris. Next up, we have a second class method that will enable us to use the data that we generated from the CSV in Iris. So to do so, we start with the usual setting up gateway and binding gateway to have our connection, and then we can use the data that is stored in Iris. To do that, we do our little query. So we want, for example, to select the length from test.data. This is the table that we created. Then we can execute this query to have a result set. And now what we want to do is create a vector in R and append all of the results from the result set in this vector. So first, we create the vector with an eval function, L equals a vector, an empty vector. And then for each line in the result set, we're going to assign, this is a new function, we're going to assign the result set.length for each line as an R expression double to the following R variable, which name is X. So this assign function takes in input the name of the variable in R and the value that we want to assign to as an Iris object. Then we just have to evaluate the append function of R in order to append our new value to the vector. Once we have that R vector, we can evaluate all different kinds of functions, for example, the mean and the median, and concatenate them as string in order to have a nice output. Then we close the connection and we disconnect the gateway. So we are going to test this little function up here. We do the class method, and as you can see, it's creating the gateway. It's going to run the query and then append all of the elements in the R container. And once it's done, it's going to do the mean and the median, as we can see. So this is one way to export data from a CSV. We can go through an SQL query and append all of the lines we want to append to an R vector. But there is another way. So as I already said, the data is accessible from Iris, but also from the R container. So we can use native R functions in order to read this CSV file. So that's what we're going to do in this method. We set the gateway, we connect the gateway, we create the connection as usual, and then we are going to read the CSV file. So in order to do that, we use the assign function to create an R variable with the path to the data. As you remember, we bound the data folder to the /temp/data, so that's why the path is like that. And then finally, we can evaluate the read.csv function to have our data frame. Once we have that, we can do the mean, we can do the median, and print them with a string method. Now, if you remember well, we connected also the script that we implemented. So we want to use these functions, and in order to do so, we are going to source this file in the R container. To do that, we create a new R variable with the path to this script. So it's in the /temp/r and /src/test.r because we put the R local folder, this one, in the /temp/r in R container. And then we can just source the R file in order to have all of our functions loaded in the R container. Once we have done that, we can, well, evaluate those functions. For example, this is the getMode function that is right here, that is going to give us the mode of the list that is here. So in our case, it's the mode of the length of all of the abandoned plants in the data frame. We can also use the createHist PNG, JPEG, and PDF functions. They have 3 inputs: the data to plot, the directory in which we want to save this data, and finally the X label. And since we are plotting rings, well, the label is rings. So we want to save those histograms in the /temp/data because since it's connected with our local data folder, we will have the histograms on our local machine right as they are created. And so after that, we close the connection and we disconnect the gateway. So we're going to try this. This is the third function from CSV on ourselves. We have the mean, we have the median, we have the mode. So it's faster because it's reading the data directly in the R container, obviously. And then the 3 plots are being produced, and we can see them now in our data folder. We can see the JPEG, we can see the PDF. Takes a little time to charge, and it takes a PNG. Don't know if PDF. Yes. So this is for reading CSV files from R. We can do both. And finally, we have a fourth little method that just gather up a little bit of everything. In this one, we create a list in which we put 2 elements. One element that is an integer with, an array of integer with 0, 1, 2, and 3 in it, and we put it as R expression integers. Another element in which is an array of doubles this time, and we can assign this list as an R expression list to the R variable X. Once we have loaded the different functions from the script, we can use the function getLength in order to get the length of this new list. Now, if we try and do this little method, it's going to show 2 because we put 2 elements in the list. So this is how the R gateway functions. But we wanted to, you can take a look to another R gateway functions. This is the community one. It's just to have a look at how we can do things differently. This one doesn't choose a Java gateway, but it uses it uses a socket connection. This is just another way if you're curious to see how we can run R code. Try this.
Thank you, Théophile. This was a very nice and great demonstration of our gateway. Thank you so much. And we have a very few time for embedded Python demo, and I give the floor to Bob Kuszewski, product manager of InterSystems. Bob?
Hello. My apologies for inevitably running a little long on this. So we're really excited about a new feature that we're adding to InterSystems Iris. we're calling it embedded Python. It's just a way of saying Python is now a first-class citizen language, just like ObjectScript, built right into the database. So this allows you to build a class alongside existing ObjectScript or a whole new application using Python in addition to or instead of ObjectScript. Obviously, Python is very important in the data science community. That's why we thought this might be a good community of people who would be interested in seeing embedded Python working alongside Iris. So let me bring up a few examples that we have here all very, very quickly. Here what we see is an Iris class that, and you see with embedded Python, you can, with any of your classes, just say language equals Python, and that is implemented in Python. So, you know, you could just, this one just says welcome, it returns true, and it prints out welcome to Python. You can, from Python, you can interact with the rest of Iris through this class, through this module that we built in called Iris. So you could do import Iris, and it lets you run some SQL. You can create a data frame from the SQL, like really, really easily. As you can see, it's just one thing. Set data frame. You can import whatever other libraries you want. I don't know if I have an example in this class for it, but you know, it's just Python code. So you could say, you know, import, you know, pandas data frame, or you know, scikit-learn, or whatever it is that you want to use for your application. You can, so let me demo that a little bit. So say I had that class right there. What did I call it? I called it user.basics. So I could do set a gets user.basics. Well, yay. Now, one thing that's pretty cool about embedded Python is you have the ability to do Iris Python Iris, which just opens an interactive Python shell. So you could do things like a get Iris, and then a gets Iris dot class basics underscore new. You notice I use the underscore instead of the percent here. That's because percent is illegal in Python. So anywhere you see a percent, you could just use dot new. And of course, you could do a dot welcome. So here, if I look at what A is an Iris class. Any Iris class, whether it uses methods that are implemented in Python or they're implemented in ObjectScript, you can access them as classes in Python and just use them like Python objects. They have all the Pythonic functionality to them. So that's pretty cool. You can also, one of the things that we have that I haven't demoed to other people yet is the ability to run Iris, well, to start with Python. So there we were running the interactive Python shell from within Iris. So you'd start it with Iris, Python Iris. You could also start it from within a terminal session just as easily. But one of the things that we're working on is the ability to have something that looks like the Python command line. In fact, it is the Python command line. It's just kind of call it Iris Python is what we call it. And I'll just put it in interactive mode. So here you're running Python, you've got the interactive shell. But you could do the same thing with if you've got something that you just written as foo.py, you could do the same thing of IrisPy foo.py, or if you run a module, like -m and then the module name, as you're accustomed to with Python. In fact, this launches python.exe. It just launches it in a way where you have access to be able to import Iris. So here we can import Iris, some SQL. And then I can say, I don't know, gets the result set.data frame. I'll have a data frame of it. Sorry, I had to load all of your Pandas stuff. And now I've got a data frame. It prints out like a data frame. It is a data frame. So that is a very, very, very quick demo of embedded Python. We're really excited about it. We're looking for more people, especially kind of Python first people, who would be interested in joining the early access program. The next phase of it with that Python, Iris Python executable that I just demoed starts next Tuesday. You can just send me email with python-interest@intersystems.com and I will add you to the list if you are interested in using Python in your AI contest. Thank you. Evgeny, over to you.
Amazing, Bob. Yes. So if as you see, you can join early access program for embedded Python and use embedded Python, your AI solution for the AI contest InterSystems sites. Okay, great. This a demo of capabilities of InterSystems Iris and that you can use in your solution. So today, the contest has been started, and we are waiting for your applications. And the next 3 weeks are for you to submit this application of open source, and it should use InterSystems Iris on the backend and should be an AI ML solution. And there, of course, will be technical bonuses for the usage of this or that AI ML specific features of InterSystems Iris, and we will announce it again on developer community site. Thank you for your attention very much. The recording of this meeting will be you could find on InterSystems developer community YouTube channel. And thank you very much. See you on developer community and in the community Discord. Have a great week. Thank you all.
You. Bye.
Bye-bye.